Imagine a warship so powerful it does not need to refuel for years, a vessel that carries dozens of high-performance jets, surveillance aircraft, and drones, and can influence events thousands of miles from its homeland. For decades, only one navy truly mastered this level of sea power, the United States. But now, a new contender may be preparing to step into that arena. China's rumored Type-004 nuclear aircraft carrier is widely discussed as a ship that could rival America's most advanced supercarriers. The real story, however, is not just about size or technology. It is about how naval power is built over time, through experience, doctrine, and the ability to operate a floating airbase in some of the harshest conditions on Earth. An aircraft carrier is often described as a ship, but that word barely captures its complexity. A modern carrier is closer to a mobile military city. On board are thousands of sailors, aviators, engineers, and command staff. There are workshops, radar centers, weapons storage areas, living quarters, medical facilities, and a flight deck that never truly sleeps. Jets take off and land in carefully timed cycles, sometimes in rough seas and poor visibility. Every movement is choreographed. Every mistake can be costly. This is the environment where both the U.S. Ford class and China's future Type-004 are meant to operate. On paper, the Type-004 is expected to be enormous. Estimates suggest a displacement between 110,000 and 120,000 tons. If those figures prove accurate, it could become the largest warship ever built in Asia and possibly one of the largest in the world. That would place it slightly above the USS Gerald R. Ford, which displaces around 100,000 tons and is currently the most advanced operational carrier afloat. But displacement numbers alone do not determine combat power. A heavier carrier can carry more fuel, ammunition, and aircraft. Yet real effectiveness depends on how efficiently it can launch, recover, refuel, and rearm those aircraft under pressure. In carrier warfare, tempo often matters more than raw capacity. Propulsion is where the Type-004 would mark a historic shift for China. It is expected to be China's first nuclear-powered aircraft carrier. That step is significant because nuclear propulsion changes how a navy can operate. Conventional carriers must refuel regularly, which ties them to supply chains and limits endurance. A nuclear carrier, by contrast, can remain at sea for extremely long periods. But the true advantage is not just endurance. Nuclear reactors generate immense electrical power. That power feeds advanced radars, sensors, command systems, and electromagnetic catapults. It also creates room for future systems such as directed energy weapons. In many ways, a nuclear carrier is a giant floating power station as much as it is a warship. The United States has been operating nuclear carriers since the USS Enterprise entered service in 1960. Over more than 6 decades, the U.S. Navy has built deep experience in maintaining reactors, training crews, and sustaining long deployments. The Ford class continues that tradition with highly modern reactors designed to produce vast amounts of electricity for current and future technologies. China is believed to be drawing on its experience with nuclear submarines as it moves into this domain. But scaling nuclear propulsion from submarines to supercarriers is a complex engineering leap. It is not only about building the reactor, but about operating it safely and reliably for decades. Aircraft capacity is another area where comparisons often attract attention. The Type-004 is projected to carry more than 90 fixed-wing aircraft, possibly even approaching 100 depending on configuration. That mix could include J-15T catapult-capable fighters, newer J-35 stealth fighters, airborne early warning aircraft like the KJ-600, helicopters, and drones. The Ford class typically deploys with around 75 aircraft, though it can surge higher when needed. Yet maximum capacity rarely equals day-to-day operational load. A carrier's air wing is carefully balanced. Fighters, electronic warfare jets, surveillance aircraft, and helicopters all compete for deck and hangar space. The goal is not to cram as many jets as possible on board, but to build a flexible air wing capable of many mission types. The launch system is one of the most technically demanding parts of a modern carrier. Both the Ford class and the expected Type-004 are associated with catabar operations, catapult-assisted takeoff and arrested recovery. Instead of a ski jump ramp, aircraft are launched by catapult and recovered by arresting wires. The shift toward electromagnetic catapults is especially important. EMALS systems provide smoother acceleration than older steam catapults and can be finely tuned to the weight of each aircraft. This reduces stress on airframes and allows a wider variety of aircraft, including heavier planes and unmanned systems, to operate from the carrier. The Ford class uses 4 EMALS catapults. Some analysts speculate that China could install a similar or even higher number on the Type-004, but exact details remain uncertain. Crew size reveals another dimension of carrier operations. The Type-004 is often estimated at around 5,000 personnel, while the USS Gerald R. Ford operates with roughly 4,300. Even at the lower figure, that is a massive human organization. Running a carrier requires coordination across aviation, engineering, weapons handling, navigation, and logistics. Flight deck crews must work in tight spaces around spinning jet engines and live munitions. Engineers keep propulsion and electrical systems stable. Command teams manage air operations and tactical decisions. Training and discipline are what turn these thousands of individuals into a coherent fighting unit. Operational experience may be the hardest factor to measure, yet it is arguably the most important. The United States refined carrier warfare over many decades, from World War II through the Cold War and into modern conflicts. Lessons were learned through real deployments, accidents, combat operations, and continuous global presence. Procedures for deck handling, strike coordination, and joint operations have been tested repeatedly. China's carrier program is newer. Its first 2 carriers used ski jump designs, and only recently has China begun operating catapult-equipped carriers. The Type-004 would represent another step up in complexity. Building a carrier is one challenge. Mastering carrier warfare is another. Airwing integration is a world of its own. A carrier's strength comes from how its aircraft operate together. Fighters defend the fleet and conduct strikes. Early warning aircraft extend radar coverage far beyond the horizon. Electronic warfare jets disrupt enemy sensors. Tankers refuel other aircraft in the air. When these elements function as a system, the carrier becomes far more than the sum of its parts. The U.S. Navy has long experience integrating platforms like the F-35C, Super Hornet, Growler, Hawkeye, and soon the MQ-25 tanker drone. China is developing its own ecosystem with the J-35, J-15D electronic warfare variants, and KJ-600 early warning planes, but integration at scale takes time and repetition. All of this connects to the idea of blue water power projection. A blue water navy can operate across the world's oceans without relying heavily on nearby bases. Nuclear carriers are central to that capability because they combine endurance, mobility, and air power. For the United States, supercarriers have long been tools of global presence, deterrence, and rapid response. If China successfully fields nuclear carriers like the Type-004, it would signal an ambition to operate farther from home and protect interests on a wider stage. So, the comparison between the Type-004 and the Ford class is not simply a contest of tonnage or aircraft numbers. On paper, China may approach similar scales and technologies. But carriers are not only built with steel and reactors. They are built with doctrine, training pipelines, maintenance culture, and operational history. Experience accumulates slowly, often through trial and error. The Type-004, if completed as envisioned, could mark China's arrival into the top tier of carrier powers. Yet matching the depth of U.S. carrier expertise is a journey measured not in a single ship, but in decades of sustained operations. In the end, the rise of new carriers does not just reshape fleets. It reshapes strategy, alliances, and how nations think about presence at sea. The oceans are vast, and influence on them has always required patience, resources, and knowledge. The story of the Type-004 and the Ford class is really the story of how nations project power, protect interests, and learn to operate some of the most complex machines ever put to sea. And that story is still unfolding.